All right, hey AP Stat. So we're gonna go over this 8.3. So it says at many high schools, prom is an annual dance that only juniors and seniors can purchase tickets for. The student council at a large high school is wondering if juniors or seniors are more likely to attend prom. They take a random sample of 50 juniors and find that 28 are planning on attending prom. They select a random sample of 45 seniors and 29 are planning on attending. Construct and interpret a 95% confidence interval for the difference in proportions of seniors and juniors who are planning on attending prom. So first thing that we want to do is we want to calculate that proportion. So if this will turn on, yeah. Nope, just okay. Okay. So for the juniors, you've got 28 out of the 50 who are actually going to go. So if you type that into your calculator, you're going to get 0.56. For the seniors, you're going to take 29 out of the 45. And if you put that into your calculator, you're going to get 0.64. Now, we're going to actually calculate the difference in the proportion. Remember, difference means subtraction. Okay, so we're going to subtract. You're going to go from juniors minus seniors, okay? And it's really important that you do that in that order. Otherwise, it will change your answer. So if you subtract those two, you're going to get negative 0.08, okay? Now, it says we are going to check the conditions needed in order to construct a confidence interval, okay? So remember, this is going to be an independent random sample of 50 and 45, okay? And then you also want to take into consideration for that 10%, you've got large counts. So that's going to be 50 times that 0.56, which equals 28, which is bigger than or equal to 10. And then you've also got 45 times that 0.64, which is going to give you 22, which is bigger than 10. Okay. Okay, so sorry about that. So that's talking about that large count, and that's actually going to give you 28.8, which is still bigger than 10. So now you're going to look at that 10% condition. So again, that's going to be, are they bigger than 10? Which they are. So you also want to check the other side. So what I mean by that is you're going to do 50 times 1 minus 0.56, which is bigger than or equal to 10. And then you're also going to do 45 times 1 minus 0.64, which is also going to be 10, greater than or equal to 10. Okay? So then when you come down here, it has a general formula and then it has a specific formula. The general formula that we always are going to use are we're going to take that point estimate and then we're going to add and subtract our margin of error. Okay? The specific formula that we're actually going to use, this looks a lot like what we've done in the past. So just a little bit different. You're going to use p hat of 1 minus the p hat of 2 plus or minus the critical value of the square root of p1 times 1 minus p1 over n1 plus p2 times 1 minus p2 divided by n2. Okay? So again, this looks a lot like what we've done in the past. So when we actually work this out, we're going to get negative 0.08, which is what we found up at the top, plus or minus the critical value. Your critical value for a 95% confidence level is 1.96, and that's something that you kind of need to know. And yes, you can look it up using that z-score table as well. So then you got 0.56 times 0.44 divided by 50 plus 0.64 times 0.36 divided by 45. Okay, So then when you do this, you're going to get negative 0.08, and then you're going to have a plus or minus of, and you're going to plug this into your calculator. I'm going to pause really quick to give you a second to try that. So then what you're going to do is you'll get 0.2 roughly, or 0.19, and keeps going. So then you're going to add and subtract that. So that's going to give you 0.12. And then also going to give you, sorry, I should do that probably in the correct order. So that'll give you negative 0.28 and 0.12. Okay. So does this interval provide convincing evidence that the juniors have a lower proportion planning on going to prom, or is it plausible that there's no difference between the two classes? Since 0 lies between these two intervals, or in this interval, there's actually going to be no difference because there's not enough convincing evidence. For it. Okay. 0 lies in the interval. Okay. And so kind of just like a rule of thumb on that is if you have an interval that has a plus plus, then that means that there's going to be more juniors. If you have a plus minus, there's going to be no difference. And then if you have a minus minus, there's going to be more seniors. And notice how we did juniors minus the seniors. So that's something to just keep in mind. Okay, so the big ideas that I want you to take away from today is that you've got a confidence interval for P1 minus P2. So you're always going to state, this is the 4-step process. You're going to state, plan, do, and then conclude. And then on that last paper, we actually didn't conclude. We would have said we are 95% confidence, and I told y'all to write down that statement. So you would always conclude at the very, very end. For stating, you're going to tell what P1 minus P2 is, which is the difference in proportions. Okay, your plan is going to say a 2-sample Z interval for P1 minus P2. Okay, you've got independent random samples. And you always have to say that they're random samples. Okay, and 10%. And then you want to also talk about large counts. Then for your do, you're going to do the point estimate plus or minus the MOE. You're going to plug in. Okay. And the last thing that we talked about is, does it have convincing evidence? And again, that's when you have the plus plus. The first proportion is greater. Plus minus, neither, or no convincing. And then minus minus, second proportion is greater. Okay, so I'd like for you to pause the video and try the check your understanding, and then we're going to get you to check your work. Okay, so the true difference of all women and men that have a second job, that's what we're actually talking about in this. And so your name of your procedure is a 2-sample Z interval. You're going to check your conditions by saying that they're random samples of each, both men and women. You check your 10% condition and make sure that this number is 1/10 of all of the women. Normal large counts, you're going to include the whole N times P and then N times 1 minus P. Make sure those are both bigger than 10. I just ran out of room. For your general formula, you've got your point estimate plus or minus the margin of error. Your point estimate was 0.03, and we found that over here. Okay, then you would plug in your critical value, which is 1.96. Plug all your numbers in. And then at the end, you are going to get an interval of So you'll have negative 0.0019 to 0.0619. Okay, and so then we would write our statement, and our statement would say that we are 95% confident that the interval from negative 0.0019 to 0.0619 will have the true proportion. I'm so sorry, that's messy. Of men and women who have a second job. And that's the entire sentence that you would actually write out. Okay? And that is your conclusion down here at the bottom. Okay? Catch you in the next one.